Okay, so day 3 of our STAAR review. So far we've talked about Pythagorean theorem. We've talked about, transformations. Both of those videos I think are really valuable. Okay. Our last 3 days of review are not going to be covering things that I think are super easy. I think that, like I've said in the last 2 videos, I think Pythagorean theorem is easy, and it's on the test a lot. I think the transformations are not as hard as they appear, and they're on the test a lot. Okay, but what we're going to be talking about in the next few days is challenging, and it's what 8th graders tend to do the poorest on. Okay, so I really want to attack these problem areas, and hopefully we can show a little improvement on these particular areas going into the STAAR test. All right, today is everyone's favorite stuff, geometry. Yay! Now, for some of you who are already going, what is geometry? Geometry is when we deal with our shapes. Now, we've already talked about Pythagorean theorem, which is a geometry lesson. Okay, so that part of the unit we've already covered on Monday. But today we're going to get a little bit more into refreshing ourselves on surface area, volume, area in general. We're going to kind of review how dilations can affect those measurements. We're going to talk about angles. We're going to cover a lot of information. Okay, where the last 2 review days was we didn't cover a whole lot. We just focused really heavily on it. Today we're going to cover a lot of different things. Okay, and it's going to kind of jump around a little bit. Okay, and so this is going to be a good thing to watch on video later, because we're going to have so much information that's thrown at you here in a second that it'll be good for you to rewatch it and hopefully be able to retain more of it with, more viewings or whatever. All right, so the first things that I want to cover, I want to talk about volume first. All right, now with volume, the good thing is that most of the volume stuff is like the formulas and everything are given to you. Normally, that's not always the case, but in this situation, a lot of that stuff will be on there. So it becomes less about knowing volume and more about knowing the formulas. If we can work the formulas, things are going to be fine. Now, y'all have seen the reference materials. If you are at home, your parents are making you do practice problems, stuff like that, you can Google STAAR reference material, and it'll bring up that reference sheet. That's all public domain, so you can all find that stuff, and you can look over these formulas. I'm going to write them out here, but all the formulas, I'll tell you if they're given to you or not, and I think that you'll see that most of them are. For volume, there's 3 different types of volume that we're going to be given. There's prisms and cone, or not prisms and cones, prisms and cylinders. There's pyramids and cones, and then there's spheres. These are the 3 types of volume that they are going to go over. Okay, now, prisms and cylinders are the most important of these 3. They're also one of the easier ones. Okay, pyramids and cones, I'm going to be honest with you, I've never seen them ask for volume of a pyramid. I've seen them ask for volume of a cone every year. But that doesn't mean they can't do it. All right, so this could be the year they do it. It's done the same way, though. All right, we're still using the same measurements, and we'll talk about it in a second. They will ask about spheres, and spheres are the easiest ones, in my opinion, because spheres, you'll see here in a second when we look at these formulas, formulas can be a little tricky, but spheres are not. Okay, so first thing we'll talk about is the prisms and cylinders. All right, as far as prisms, they're going to ask us about 2 different types of prisms. Okay, they're going to ask us about rectangular prisms. They're going to ask us about triangular prisms. And then they'll ask us about the cylinders. Okay. I'm a good artist, aren't I? It's great. I think so. All right, so for all three of these shapes, on your formula chart, the formula given to you is V equals capital B H. Okay? Now, the problem with the formulas is they don't tell you what any of these letters mean. There's no formula key. I wish there was. All right? But we need to be able to identify what these formulas, what the letters mean. And so we've talked about this quite a bit, but I know 8th graders, and at least half of you in here have forgotten. So when I ask 8th graders what capital B stands for, most of them say base, and that's wrong, right? Yeah, what does capital B stand for? Area of the base. Good. All right. Area of the base. All right. If it's a lowercase b, that is base. But a capital B, now we're talking about the area of the base. All right. Capital B is reserved for 3D shapes, okay, where we have multiple sides that we need to look at. All right. And then H is exactly what you would think. It's height. Okay. Now, we need to make sure that our 8th graders can identify what the base is and what the height is. Okay, and you would think that's easy, but it's not. Okay, most 8th graders will tell you that the base is what's on bottom, and that's not true. Okay, the base is what's on bottom for this shape. This is the only one. The rectangular prism is the only one where the base is what's on bottom. Okay, so for this shape, it would be this right here. What's on bottom? Okay, does everybody see that? All right. For the triangular prism, it's what the shape is named after, which is the triangle, right? All right. So a lot of 8th graders will try to say that that rectangle on the bottom is the base, and if you do that, you're going to be wrong. We have to recognize that the triangular prism uses the triangle as its base. We need to be able to identify that. All right, and then I think most of you understand that cylinders, the base is the circle. Okay, so area base, what the shape is named after. If it's a rectangular prism, it's whatever's on bottom. Okay, then we talk about height. Height is not how tall the shape is. Okay, we got to remember that if I take a Coke can, that's a cylinder, right? And it is probably about 5 inches tall. But if I lay the Coke can on its side, the height is still 5 inches, even though at that point it's only like 3 inches tall. You understand that? Okay, and I'm kind of just, it's just like I can use the marker. You can't see it on the video, but this marker is about 6 inches tall. It's a 6-inch height cylinder. If I turn it on its side, it's only ½ an inch tall, but it's still a 6-inch height cylinder. Okay? Height can't change just because of how it's standing. All right? So, the definition that we use for height is how far apart the two bases are from each other. Okay? So, if we're using the base here, it would be from here to here. That would be my height. Okay? For the triangular prism, it's the distance between the two triangles. So, this right here would be my height. All right, and then cylinders are, like I said, they're not too bad. It'd be the distance from circle to circle. Questions there? Okay. So now that we know the area of the base and the height, okay, we need to plug in what it is that we're solving for. Okay, now if you are doing the volume of the rectangular prism, what shape is our base? What shape is our base?
Square or rectangle?
It's a rectangle, okay? So, if you look on your formula chart, it'll say area, rectangle, and it's lowercase b, h, all right? That is my area of the base. That's how I would find that. Times H. Now this makes it confusing because I've got two H's, but they're going to be different things. Okay? And let me show you what you need to do here to make sure you don't get confused. This part right here is only talking about the base, right? So whenever you get to a volume or a surface area problem, the first thing you should do is redraw whatever your base is. Okay, I'll do the same thing over here. Redraw it off to the side. So now I know that this base and height that they're asking for is talking just about that shape, not the whole 3D shape. Whereas this H is talking about the height of the whole prism. Okay? And we'll do some actual examples here in just a second, but I know that this can be tricky. With the triangular prism, okay, if you look under area of a triangle, it would be 1/2 BH times H. We're still using this formula up here. All right, so again, this 1/2 BH is the area of this, so we're only looking at that shape. Whereas the height here is talking about the entire prism. And then lastly, with cylinders, cylinders are actually the easier ones, believe it or not, because if you look under area for circle, it would be pi, well, I want to do that in red. It would be pi r squared times the height of the cylinder. Okay. Now, usually they tell you, but if you don't know, pi is 3.14. Okay, there is a pi button on your calculator, and you can use that, but your answer is probably going to be a little bit different than what they have on the answer choices. What is the R?
Radius.
The radius. And what is a radius?
The distance between like the edge to the center.
Yes, it's the halfway mark. What goes all the way across the circle? Diameter. Okay, we got to make sure we know those two things. Radius is halfway. Diameter is all the way across. And then, again, this height is talking about the entire cylinder. So, I'm going to do one practice problem in each one of these shapes because we do have other things to cover. But it'll give you an idea of what we're looking at. So, let's start with a rectangular prism. Okay. That's as good as I'm going to get. All right, let's say this is 20, 12, and 8. All right. The formula for volume is volume equals capital BH. Okay, what does the capital B stand for?
Area of the base.
Area of the base. So, area of a, what is our base going to be? What's the shape of our base?
The square.
Not a square.
Rectangle.
It's a rectangle, okay? So, area of a rectangle is BH, and then we still have the times H. So, that's here and here. Okay, so I told you the first thing that you should do is redraw your base, okay? And we just said it's a rectangle. What are the measurements of that rectangle?
12 by 20. Oh,
Of just the base.
12 by 20.
Yeah. 20, which is right here, and 12, okay, which would go right here, which we know is the same as that, right? Okay, so we know if we're looking at just the base here, what is the base of the base? 20. All right, here's our base. There's the base of the base. All right. See, we start repeating words, and I hate that, but that's just the nature of the beast. It's why people struggle with this. All right. What is the height of the base? 12. Okay. Times, what is the height of the cylinder? 8. Or not cylinder, the prism. I'm sorry. 8. 8 is the height overall, right? So now we can put all this in our calculator. You get, what, 20 times, that would be 96, which would be 1,920. I don't know. Is that what it is? Look at me go. 1,920. All right. We would put this right here in our calculator. Let your calculator do the multiplication. You don't really have to worry about it. Okay? It's about knowing what to plug in. Okay? And I know that it can get confusing because of the base of the base and all that fun stuff. All right. Let's look at a rectangular or a triangular prism. Okay. Let's say this is 20, 10, and 5. All right. Again, volume is equal to capital B H. All right. Well, the volume is equal to the area of the base. Area of a triangle is 1/2 base times height times the height of the prism. Okay. So again, that's here. That's there. All right. So first thing you should do is what?
To redraw the.
Redraw the base. Good. All right. We have a triangle. I don't know if it's a right triangle. It's a triangle. It should be a right triangle. All right. Which is 10 by 5. Okay. So now I'm going to rewrite all this. So instead of 1/2, what could I put that's easier in the calculator?
0.5.
0.5. That's a little bit easier. You don't have to do that, but I find it easier. All right. Times, what's the base of the base?
10.
10. What's the height of the base?
5.
5. What's the height of the prism?
20.
20. And that can be tricky because it's not how tall the prism was, right? It's the distance from triangle to triangle. Good. All right. And that would give you 500, I believe. But I don't know. You just put that in your calculator and you're good to go. Okay. All right. Lastly, we have the cylinder. Okay. Let's do this. All right. Let's say this is 20 and this is 5. All right. So volume equals capital B H. Okay. What type of base do we have? A circle. So area of the base, area of a circle is pi r squared times the height of the cylinder. Now, if we redraw that base, all right, what's pi? 3.14. What's my radius? 10. Good. They're going to give you 20 to try to throw you off. 20 is the diameter. 10 would be our radius. Times, what's the height of the cylinder? 5. All right. You put that in your calculator, you're home free. All right. So there are, right there, 3 different examples of volume of each shape. Okay. We don't have time for me to do more. All right. But if you're watching this video at home, you can always just Google practice problems. I promise. There's a billion online. It's crazy. Okay. So you can rep that out if you need to, but you do have examples for you to watch. If there's any more clarification you need, just come see me in the morning, and I'll do my best to further clarify, because I know that it can be tricky. All right. So now let's talk about surface area. When we talked about volume, volume was how much space was inside of that 3D object, right? If we're talking about volume of a fish tank, we're talking about how much water would it take to fill up that fish tank. Okay? Surface area is exactly what it sounds like. It's the area of all the surfaces. Okay? It's how much paint would it take to paint the glass on that fish tank. I don't know why you would do that, but hey, people are crazy. All right, so there are 2 different types of surface area. There's lateral and there's total. Okay? We have surface areas of prisms and cylinders. Okay? Again, prisms can include triangular prisms and rectangular prisms. Okay? Now, for lateral surface area, the surface area of a prism would be capital P, H. All right? And the total surface area would be capital P, H plus 2 capital B. What does the P stand for here, the capital P? of the base. It's capital P, so it's the perimeter of the base. Okay, perimeter of the base. All right, times the height of the prism, just like we did last time. All right, what does the total surface area include that lateral does not?
The base times 2.
Yeah, the two bases. Okay, every prism had two bases, right?
Yeah.
All right, if it's the total surface area, we're going to also include the area of those two bases. If it's the lateral surface area, we're going to leave those out. We're just going to look at the outside surfaces. Okay, so if it was a triangular prism, we're not going to include the two triangles. Okay, so that should be easy to remember because you can just look at the formulas which are given to you and be like, hey, this one has bases. You know what I mean? So with cylinders, they kind of give you a break. They don't make you plug in certain things. So, but the cylinders, you do 2 pi r h. 2 times pi times the radius times the height of the cylinder. If you're doing total surface area, 2 times pi times r times h plus 2 pi r squared. Now this would have been a pain in the butt before calculators. With calculators, it's not too bad. You guys are pretty good at typing all that in and it not giving you any troubles. Okay, so let's look at some surface area stuff. Okay, let's say you had, let's go with, we'll say 12, no, let's do this. All right. One of the things they love to do, what did I do to be mean?
You put 1 feet instead of inches.
Yeah, they have one of the measurements in feet instead of inches, okay? At which point you would just go, there's 12 inches in a foot, and you'd be fine. Okay, so just keep an eye out for that, just in case they do try to trick you. All right, now, we're going to find the lateral surface area and the total surface area of this shape. Just like we did last time, the first thing you should do is redraw your base. This is a 12 by 8 inch rectangle because it's what's on bottom. Okay. All right. So lateral surface area is capital PH. Perimeter of the base. How do you find the perimeter of a shape?
Add up all the sides.
Add up all the sides. 8 and 12 make 20, 28, and 40. All right. So the perimeter of the base is 40. Just adding it all the way around. Times what's the height of the prism?
10.
10. 40 times 10 is 400. That would be the lateral surface area. Okay? It's not that tricky if you know what to plug in. Now, total surface area is capital PH plus 2 capital B. We just said what pH is. What is it? 400. Plus 2 times, how do you find the area of a rectangle?
Length times width.
Length times width, base times height, either one. 8 times 12 is 96. Which would give you 592, I think, if you put in your calculator. Tricky? Not too bad? Cool. All right. Rectangular prism. Okay, let's say we have 5, 10, 8, and 12. All right. Lateral surface area, perimeter of the base times the height. First thing I do is redraw my base. What are the 3 dimensions?
5, 10, and 8.
And 8. Good. If they were wanting to be rude, they could make you do Pythagorean theorem to find this last one, but hopefully they don't do that. All right, so perimeter of the base, 5 plus 10 plus 8, that's going to be 23. What's the height of this prism? 12. Good. I don't know what 23 times 12 is. You'll have calculators.
It's 276.
276. Good. All right, perimeter of the base times the height plus 2 times the area of the base. All right, so we have 276, which we just solved, plus 2 times the area of the base is 1/2 times the base of the base times the height of the base. All right, so that would be 25. 0.5 times 10 times 5 is 25. Okay, so we add those up. You get 326. Is what it should be. All right, and then lastly, cylinders are really not that bad because they tell you exactly what to do. All right, let's say this is 5. This is 10. I think that's all we need. All right, lateral surface area. Lateral surface area is gonna be 2 pi r/h. All right, so 2 times 3.14 times 5 times 10. It's gonna be what? 314, right? All right, so that would be my lateral surface area. Total surface area is 2 pi r/h plus 2 times pi r squared. That's total surface area. All right, we just said 2 pi r/h is 314 plus 2 times 3.14 times 5 squared. Now you can put all that in your calculator, and you're going to have an answer. All right, so that is surface area, okay? Those are all 3 types of surface area you're going to see. Prisms, rectangular prism, triangular prism, and cylinder, okay? Lateral surface area, total surface area. Again, I know we're moving fast. There's a lot to cover. That's why I'm saying you're going to want to rewatch this video. But it's less about knowing how to work with the numbers and more about knowing what to plug in where. If you know what to plug in where in the formulas that it gives you, you can let your calculator do all this heavy lifting for you. Okay? But if you don't know how the formulas work, you're going to be in for a hard time. Okay? So, as you're preparing yourself for STAAR tests, you're studying all the stuff we did on Monday and Tuesday. When you go to study this, study those formulas. Figure out how the formulas work. Make sure you understand them and what you're supposed to do. Okay? If you can't tell me that capital B is area of the base or capital P is perimeter of the base, then you're not prepared for the STAAR test. All right. Couple other things that I want to talk about just while we have time. When you have 2 angles that make this right here, how many degrees is that?
180.
All right. If it equals 180 degrees, that's what we call supplementary. This right here equals 90 degrees. Anybody remember what that's called?
Right angle.
When you have 2 angles that make a right angle. Anybody remember the word for it? Hey, somebody said it. Complementary.
I thought that was wrong, so I was like,
Yeah.
I misspelled that. Complementary. There we go. Complementary. All right. Doesn't come up too often, but those are 2 key words that it's good to know just in case they do come up. Because if you don't know them and they're like, these are supplementary angles, you're going to be looking at supplementary like, I don't know what that means. Okay? So it's good to know these. 90 comes before 180, right? Well, complementary comes before supplementary in the dictionary, so that ought to help. Okay, try to keep them from getting confused with each other. All right. All right. If you're given a triangle, what do I know about these 3 angles?
they add up to 180.
There we go. All right. No matter what triangle I draw, if I take these 3 angles, they'll equal 180 degrees. These 3 angles will equal 180 degrees. All right. These 3 angles will equal 180 degrees. So Alright. Doesn't matter if it's acute, obtuse, right? It doesn't matter. Scalene, doesn't matter.
Is there a way for them not to equal 180?
Nope. There's no triangle that will that you could make that with the three angles wouldn't equal 180. They have to. Okay? It's a rule. Okay? If you come up with a triangle that the three angles don't equal 180 degrees, you're going to break the universe because it's never been done. Okay? All right. So we can use that. If you're given two angles of a triangle, we can solve for the last angle just by subtracting from 180. Okay? To the point where I can say, all right, let's say you have this triangle here. What does that mean right there? It means those are the same angle, right? And let's say this is 45 degrees right there. And I want to know the measure of that angle.
You subtract 45 from 180 and divide it by 2.
Good. I know I could take that 45 away. Okay. And I know that these two angles are going to equal 135. So you divide 135 by 2, I think you get 67.5. All right, and that would be the measure of the angle. Okay, so we can do a lot of work finding missing angles of triangles. Okay, one of the triangles that did come up was something like this. All right, we call that an exterior angle. Okay, the rule for exterior angles is that the exterior angle is equal to the two opposite interior angles. These two equal this one. Okay? Because we know that these two angles are going to equal what? 180 degrees. We also know that these three angles are going to equal 180 degrees. All right? And they both have this angle in common. So if I take them away, what's left should be equal to each other. Okay, so that's the exterior angle theorem. If they ask you a question over it, if you know that, hey, this is the same as these two put together, then that makes those really easy problems. But if you forget that, you're never going to remember it. It's not one of those things that's easily remembered. All right. Let's see. You could be asked about this right here, where we have three lines, two of which are parallel. Okay. We got to remember that all of these obtuse angles are equal to each other. All of these acute angles are equal to each other. All right, those are all congruent to each other. All right. We call this alternate exterior angles because they're on alternate sides of the transversal line. Alternate exterior because they're opposite sides outside of the parallel lines. All right? Just like these would be alternate interior angles. Okay? These would be same side interior angles. These would be same side exterior angles. Okay? Little keywords that we learned way back when. In 3 years, I've only seen them ask one question over transversal lines, but that doesn't mean it's a bad idea to look into. All right. Last question here that I'm going to ask before I turn this video off. If I have this grid right here, how do I find the distance from this point to this point?
You go down and over.
Rise over.
I make the right triangle. Count my spaces, and do what?
You square them.
Pythagorean theorem. Good. Now you're going to go deep. All right. Okay. Again, we covered a whole lot right there. Okay? And I promise some of you in here have got to be confused because it confuses me sometimes. All right? All I can say is it's best to just watch it a couple of times. All right? You don't have to watch the whole video. You may understand, how to deal with cylinders, but it may be triangular prisms that are messing you up. Okay? Go skip around and watch those parts of the video. That's fine. Okay? But really kind of review the things that are getting you confused, and hopefully that'll get us caught up. Okay? All right.